Hi, this is a little video, Algebra 2, simplifying radical expressions containing binomial denominators. Okay, so in order to be able to do this work, you really need to understand the product property of radicals and the quotient property of radicals. So it starts out, for real numbers a, that are greater than equal to 0 and b that are greater than equal to 0, we can say that the square root of a times b is equal to square root of a times the square root of b. Now, what I want you to do is I want you to think about, what does this mean? Why are they even saying this? Why are they saying a has to be greater than or equal to 0? Well, what you need to think about is, what are they not saying? What are they saying it can't be? And basically what they're saying is a can't be a negative number. And if you think about it, if a was a negative number, right, we'd have the square root of negative 4. Well, can we find the square root of negative 4? No, that's not possible, right? Because we can't find any number that multiplied by itself will equal negative 4, right? The possible answers could be 2 times 2, but that's equal to 4. And then if we have negative 2 times negative 2, that's also equal to positive 4. So we can't get to negative 4. So that's what this is all about right here, okay? That's why a has to be greater than or equal to 0. Basically what it's saying is it can't be negative. And then down here, same rules apply, right? Same basic rules, but then the square root of a divided by b is equal to the square root of a divided by the square root of b. Let's take a look at this in action here. And let's say we have the square root of 12. Well, what we can do is we can break up the square root of 12 into some of its factors and say the 12 is 4 times 3, right? And then we can say, then we can apply this property and say the square root of 4 times the square root of 3, right? Square root of 4 is 2, and times the square root of 3. So let's take a look at it here for quotient. And we could break this up into the square root of 1 over the square root of 4, and that's just equal to 1. The square root of 1 is 1, the square root of 4 is 2. It's just equal to 1/2, okay? So let's look at this. Write the expression in simplified form. 4 plus 3 times the square root of 7 over 3 minus 2 times the square root of 7. Now you can use the difference of squares pattern to rationalize the denominator. Right? When the denominator of a fraction is a binomial expression that includes a radical, multiply both the numerator and the denominator by the conjugate. Now remember, this is a fraction. The top part is called the numerator, the bottom part is called the denominator, and we are looking at a binomial, right? Two monomials, binomial, an expression that includes a radical. There's a radical here. So we will use this thing by the conjugate. Let's take the conjugate multiplied by the conjugate. Let's take a look at what the conjugate is. So here is the definition of the conjugate. The conjugate of a plus the square root of b is a minus the square root of b. Just look at both of them. Compare and contrast. What do you see? The only difference is on the one. It's the sign is the opposite. So now let's take a look at our denominator. 3 minus 2 times the square root of 7, right? It's a binomial expression with a radical sign, right? So what would be the conjugate of this? Well, the difference in the conjugate is that we've got to make this negative sign a plus sign. So we go 3 plus 2 times the square root of 7. That's going to be our conjugate. Okay, there it is right there. So let's solve this now. Now, we're going to multiply our expression, our rational expression, by the conjugate. And remember, it's the conjugate over itself. And why are we doing that? Because remember, anything over itself is equal to 1, right? 12 over 12 is equal to 1. Anything over itself. So if we multiply by 3 plus 2 times the square root of 7 over 3 plus 2 times the square root of 7, it's just like multiplying by 1. So now we're going to use the distributive property, and we'll just go 4 times 3 is 12. 4 times 2 times the square root of 7 is plus 8 times the square root of 7. And then we've got 3 times the square root of 7 times 3, that's going to be plus 9 times the square root of 7. And then 3 times the square root of 7 times 2 times the square root of 7. 7 is 3 times 2 is 6. Square root of 7 times the square root of 7 is just 7. Okay. I know my writing is not the best, but we'll make do. 3 times 3 is 9. 3 times the 2 times the square root of 7 is plus 6 times the square root of 7. And we will just keep on going through. So minus 6 times the square root of 7. And then minus 4 times 7. We'll kind of clean this up a little bit, and we get 12. And this is 42. 12 plus 42 is 54. And we get 8 plus 9 is equal to 17, plus 17 times the square root of 7. Well, look at here. We have a plus 6 times the square root of 7 and minus 6 times these just cancel out, equals 0, right? And we have a negative 28. Negative 4 times 7 is negative 28, and a positive 9. That's going to leave us negative 19. Okay, so that is the answer. And let's take a look. So basically what we're saying is 4 plus 3 times the square root of 7 over 3 minus 2 times the square root of 7 can be simplified and is equal to 54 plus 17 times the square root of 7 over negative 19. Okay, I hope you found this helpful.